All right, y'all, this is the review for 6b and 7. Basically, we're doing antiderivatives and the fundamental theorem of calculuses, which are basically antiderivatives also. So let's jump right in here. Remember, there are usually two ways to do antiderivatives. The first way is to do U substitution, right? U substitution. And the second way is to maybe look for some type of an arc trig situation. Okay, so we have U substitution and arc trig. Those are basically our two ways of doing things. So let's jump right in and see what we can have here. Okay, so notice there's a plus on top. Okay, so I'm going to split this into two integrals because the numerator is not the derivative of the denominator. Okay, if it was, then U substitution would be really easy. Okay, but because the numerator is not the direct derivative of the denominator, I'm going to break this into two integrals. So I have x over x squared plus 9, and I have 3 over, right? This is something we can do with fractions, that if we have a plus in the numerator, we can separate that plus into two separate fractions that I'm adding together. Okay, so I'm going to take the derivative, or rather the integral of each of these things separately. Okay, for this one, I'm going to use U substitution. Okay, and I'm going to call U my x squared plus 9. And over here, this other guy, I'm going to use an arc trig type of an antiderivative. Okay, I'm going to pull the 3 out to the front, right, because that's what we do here. Okay, so that's my job, is the first one. This one I'm going to use U substitution on, and the second one I'm going to use an arc trig on. Okay, so I'm not going to explain it. I'm just going to pause the video, do all of the work, and then you'll be able to see it when I come back, which will be in literally 1 second. And there you go. Okay, so we use U substitution. We have du is 2x, so then dx is tu over x. Okay, when we replace that into here, right, the x's cancel out, and we have du over 2u, which is a natural log antiderivative, and then we replace the u. Okay, here, hopefully you notice this is an arctan type of an antiderivative with u value of x and an a value of 3. So 3 from the front, 1/3 arctan x over 3. Okay, we multiply 3 times 1/3, and remember to add this plus c, because every indefinite integral is going to have a plus c in it. Okay, moving on. So notice here that your numerator has a higher power than your denominator. Okay, so first we're going to use some long division in order to change this into two separate, right, we're going to find the integral of two things. We're going to split this into, we're going to split this into 2. Okay, so we're going to use long division so that we have something that's more easily capable of taking the antiderivative. Okay, so I'm going to pause the video and do that right now. So we get x minus 2x over x squared minus 1 when we do long division. Okay, so now I'm able to break this single, right, subtraction into the integral of the left one, which is x dx, minus the integral of 2x over x squared minus 1 dx. Okay, so hopefully this left guy is pretty easy for you to do, and we're going to use U substitution on the right guy. Okay, so here we're going to have u be the x squared minus 1. Okay, so I'm going to do that and come right back. Okay, and this is what it sets up like. So we have already the 1/2 of x squared over here. And then this one, hopefully you notice the 2 x's will cancel out. And I'm going to be taking the integral of du over u, which hopefully you understand is known as the natural log. So we're going to take the natural log, and then we're going to replace u again with the x squared minus 1, which is what we said u was up here. So 1 over u, or du over u, has an antiderivative of natural log. And then we have to, of course, put in our plus c. And that is your final answer. Okay, we're going to do U substitution here as well. And the hard part here is the e, we're going to call it e to the root x. So we're going to let u be the whole thing, e to the root x. Okay, so then the derivative of e to the root x is e to the root x times the derivative of root x. So remember, well, maybe you don't remember, but root x is x to the 1/2 power. So you subtract 1, right? You bring the 1/2 to the front, and you subtract 1 from the power when we're taking a derivative. So this becomes 1 over 2 root x. dx. Okay, so when we take the derivative of e to the root x, that is e to the root x times 1 over 2 root x, because we have to take the derivative of your power, which happens to be this. Okay, so now when we solve this thing for dx, I get 2 root x du over e root x, right? So that is my dx when I'm going to come over here and substitute. So let's see what that looks like. I have u in my numerator, okay, and I have root x in the denominator. Now I'm replacing dx with 2 root x over e to the root x times, of course, du. Okay, so let's see what happens. This root x here and this root x cancel out. Now I have a problem with my e to the x. Well, I already said e to the root x is u. So I'm going to once again substitute e to the root x as u, and my u's cancel out also. So I'm just looking at the antiderivative of du, which is just u, right? Because it's 1, and the antiderivative of 1 is the single variable. So now I can come back here and replace u with my e to the root x. And, oh, wait a second, there's a 2 here. I am sorry, I apologize. This is a 2 du. So I have 2u, which is a 2e to the root x plus c. And that is my final answer. I am sorry, I apologize. I forgot about this little u that didn't cancel out. So it's the integral of 2 du, which is 2 times a variable. And your u was e to the root x plus c. Whew, almost. All right, so we're going to continue on with that notion, coming down to here. Okay, now what we've looked at is things with roots in the denominator should remind you of some type of arc trig antiderivative. So we want to make this thing into an a squared minus u squared deal. And we're going to do that by completing the square. Okay, so I have 8 plus something minus, so I'm going to pull out my minus here to make this a positive x squared. I'm going to change this to a minus 2x and then plus a box. Okay, so now this makes sense. If I have a plus here, but then I'm subtracting it, then I'm also going to have a plus here in between my 8 and my box. Okay, so this is a plus, and this is a plus in parentheses, but it's actually a minus, so these ones are going to negate each other. So I'm not actually changing my problem. So I'm going to put a 1 in each of these boxes because that's how you do to complete the square. Okay, now this becomes a perfectly factorable quadratic to x minus 1 squared. And of course, 8 plus 1 is 9. Sorry, that's not a plus in the middle. That is a minus. Right? This was a minus here, so that's a minus there. So now I'm looking at the integral of dx over 9 minus x minus 1 squared. Okay, now hopefully you recognize this as being an arc sine trig antiderivative. Okay, so we have a squared, the number is 9, so a is going to be 3, so that goes in the bottom of your denominator here. And x, the u part, is the x minus 1. So we're going to put x minus 1 on the top there. Okay, you can, if you want to, you can parenthesize these things, and of course, to finish off, we're going to add our plus c. Okay, so I'm going to rearrange things and get everything back in the box, so hang on one sec. There, that's better. Okay, so number 5, hopefully you also notice this one as being some type of an arc trig antiderivative. Okay, so it has a square root of a squared minus u squared. Okay, so hopefully you recognize that as also being an arc sine antiderivative. Okay, arc sine. So our a value is 1, and our u value is going to be, let's see, u squared equals 4x. So u has to be 2x, right, when you take the square root. So arc sine of 1 over 2x plus c. So when you recognize these things, right, the antiderivative is pretty simple. So hopefully you recognize this one also as being an arc trig. In fact, this is an arc secant antiderivative, right? We have u on the outside, we have a u squared minus 1 sort of looking business. But looking at this, this part, right, this should be the square root of that one, right? This is u and this is u squared. So u looks like it's going to be 3x, but this is just an x. So we have to do some manipulating here and put this u over 3, right? Because that's not quite exactly what we want it to be in this type of our equation. Okay, so we're going to change this a little bit to put a 3 on top. Okay, and now it looks like we need to have, that's better. And this is why we're able to do that. We're just going to come back and let me talk about U substitution real quick. Okay, so this is why we're able to put a 3 up there. So we're going to let u be 9x squared. Then du is 3x dx. No, it's not. It's 18, isn't it? It's 18x dx. Sorry, what am I thinking here? U squared is 9x squared. Okay, that's true. Sorry, let me come back here and get my thoughts right. So u is 3x. Check, right? That's this part. There's our u squared. So x equals u over 3, right? And that's what we get here. Our x is u over 3. So then du equals 3 dx's, right, from right here. If u squared is 9x squared, then u is 3x. So then du is 3 dx's. So du over 3 is equal to your dx. Okay, so if we do our U substitution, right, we have 1 over u over 3, right? That's what x equals. So x is u over 3 times the square root of u squared minus a squared. Okay, times, right, our dx was du over 3. Okay, since we have a 3 and a 1/3 down here, right, those 1/3 and those 3's cancel out. So we have a 1 over u, right, 1 over u times u squared minus a squared. Sorry, that was a long way of saying that that's what we can do. Okay, so we have the arcsecant of, let's see, it's u over a, right? U over a is what goes in here. Okay, so u is 3x and a was 1 plus c, and of course we don't have to have the division by 1, so just arcsecant of 3x. Okay, and that's what goes into your guy right there. Okay, so that one might have been a little bit, I don't know, convoluted, but that's what we want for our answer. Arcsecant of absolute value 3x plus c. Okay, be able to recognize which arc trig it happens to be. Okay, so number 7. All right, we're going to pull the 3 out to the front. 3 times the integral of 1 over x squared plus 5. Okay, hopefully you recognize this as an arc tan an arctan style antiderivative, right? We have u squared plus a squared. So u is equal to x and a squared equals 5, so a is root 5. So I have 1 over root 5, and I have x over root 5 plus c. Okay, and don't forget we're multiplying all of this by 3, right, because of the 3 out front here. So we have 3 over root 5 arctan of x over root 5 plus c. Okay, over here, the first thing we're going to do is take this 3 and bring it to the front. Okay, so we're going to have 3 times the integral of x over x squared plus 5 dx. Okay, now this is an excellent one for U substitution because you notice that the numerator is basically the derivative of the denominator. Okay, so if the top is a derivative of the bottom, U substitution is a really fabulous thing to use. Okay, so we're going to let u be x squared plus 5. So du is 2x dx. So we have du over 2x. Okay, so we're able to do our U substitution. And we replace all these things. So this is x over u times du over 2x. Okay, so then the x here and the x there cancel. And once again, we're going to bring this 2 in the denominator outside, also in the denominator. So we'll have 3/2 times the integral of du over u. And hopefully you can recognize the du over u is the natural log antiderivative. So we have a 3/2, and I let u be x squared plus 5. That's an x squared, by the way. It does not look like it. X squared plus 5. And then we have, of course, our plus c. Okay, so one style where we have a number on top, that's an arc trig. Here we have a variable on top, so this is going to be a U substitution. And now we have where the denominator and the numerator have the same power, and this is going to be a long division. Okay, what we're going to long divide is split this into some other different things. So x squared plus... How many times does that go into 3x squared? Well, the answer is 3 times. So we have 3x squared plus 15. All right, when we subtract, we get a minus 15. So we're going to rewrite this as the integral of 3 plus, or rather, not plus, minus, since this is negative, minus 15 over x squared plus 5. Okay, so now I'm going to separate this into 2 integrals, the integral of 3 over, and then our, once again, 15 over x squared plus 5 dx. Okay, so the first one is just a constant, so that will antiderive to 3x. And then the second one here, right, this is the same as number 7 from a minute ago, a number over x squared plus 5. Right here we have a number over x squared plus 5, so it's going to be an arctan antiderivative. Okay, so minus 15 with, let's see, a u value of x and an a squared equals 5, so a is root 5. So 15 over root 5 arctan of x over root 5 plus c. Okay, so these are the 3 different types of problems we have. We have one that's just straight up arc trig. We have one that's a U substitution, and then one that is a long division, which separates into a simple antiderivative, and then we have, in this case, another arc trig. Okay, so moving on to 10. Now we have to find each definite integral. So notice we have a lower bound and an upper bound. So we're going to take the antiderivative and plug in these numbers. Okay, so this one, let's try U substitution. So we're going to let u be x squared plus 6x. So du is 2x plus 6 dx. So du over 2x plus 6 is what we're going to replace dx with. So the integral from 1 to 3 of x plus 3 over u times du over, now I'm going to do something strange, and that is factor my 2x plus 6 into 2x plus 3's. Okay, and of course I think you can see why I want to do that is to cancel out the x plus 3's. Okay, so the denominator 2 is going to come out here as a 1/2, right? And we have the integral from 1 to 3 of 1 over u du, which hopefully you recognize as being a natural log antiderivative. So the natural log of x squared plus 6x evaluated at 3 and 1 and then subtracted. Okay, so there's a little bit of algebra. I'm going to pause and do the algebra just to save on time. So we get down to this part. Half the natural log of 27 equals half the natural log of 7. So what we're going to do is take the 1/2 and plug it into as a power, right? This is one of our rules of logs, is that we can do this. So now I have natural log of 27 to the 1/2 minus natural log of 7 also to the 1/2. Okay, so if we're raising something to the 1/2 power, that's the same as square rooting. So square root 27, square root 7. Now I'm going to use another property that says if I am subtracting logs, that's the same as dividing their arguments. Okay, subtraction becomes division. Well, root 27 divided by root 7 is root 3. Okay, and that would be your final simplified answer all the way down to root 3. Okay, lots of natural log stuff in there. Okay, so similarly here, we're going to complete the square in your denominator so that we can separate this stuff into two different, what do we call them, integrals, and take the antiderivative with something special. So this is x plus 3 squared plus 4. Okay, so maybe you don't recognize this, hopefully you do. At one point in your life you're going to. This is an arc tan antiderivative. Okay, with an a value of 2, because that's your square root of 4, and a u of x plus 3. So we have 1/2 the arc tan of x plus 3 over 2, and we're going to evaluate that from -3 to -1. Again, a lot of algebra, so I'll pause and come right back. And we get to here. So this is asking us at what angle on your unit circle is the tangent going to be 1. And that happens at pi over 4. That is the unit circle angle where tangent is 1. And this one is asking us what is the angle on the unit circle where your arc tan is 0. And that happens at 0 radians or 0 degrees. So basically this is just pi over 8, half of pi over 4. Okay, and that is the first page of this review. Right? There's a lot of stuff here. They're all antiderivatives. You can do U substitution or some type of an arc trig antiderivative.